Algebra 1 Common Core Regents Review Quiz 3 Study Guide. So this is the third video in the Regents Review series to prepare my class for a quiz. You might just be watching it as you get prepared for your Regents Review. That's fine too. So this video is going to cover a few things. It's going to cover some factoring skills that maybe we haven't seen in a few weeks, some operations with polynomials that we have seen, but still we need to always make sure we're sharp with our polynomial algebra skills. That's a big part of this course. Solving literal equations, which is, just like solving equations, but there's a lot more variables involved. And basic inequality graphs. So first, factoring. Probably the most complicated version of factoring we have is called AC factoring. And, first of all, how do I know it's AC factoring? That's a big part of the question. Just check and see what color I got there. Looks like the bottom of my screen's a little cut off here. Sometimes the toolbar doesn't quite disappear like it's supposed to. But that's okay. We'll just go with black. So I know it's AC factoring. First of all, it's trinomial factoring because it's got three pieces. But it cannot be basic trinomial factoring because of the number that's in front of the x squared. And remember, for all types of factoring, we always look for GCF first. And in this case, there is no GCF. So there's no GCF, there's a number in front of x squared. That means it has to be what's called AC factoring. And so the first step in AC factoring is actually to make a note off to the side as to what AC is. And AC comes from your first times your last, your A term times your C term. And in this case, it would be negative 9x squared, or just negative 9 if you want to just think about the numbers. Then what we use is we use the AC. We think of things that multiply to that. So we're looking for things that multiply to that negative 9 and add to the 8 that we have in the middle. And in this case, multiplies to negative 9 adds to 8 is going to be positive 9 and negative 1. They multiply to negative 9 and they add to positive 8. We use this as a way of expanding our trinomial to make it a 4-term. So we keep 3x squared in the front the same. But then we replace 8x with two new terms. We replace it with a positive 9x and a negative 1x. And again, those came from the numbers that multiply to AC and add to B. And then we bring down the C term. Now it's successfully been expanded into 4 terms. Once it's 4 terms, we do factoring style called grouping, where we slice it in half and we GCF on both sides. The greatest common factor on the left is 3x. Really, you're looking at the numbers 3 and 9 could both be divided by 3, but they both also have an x. And when you take 3x away from both sides, you're going to be left with x plus 3. And what I mean by take away is really divide. Right? Divide 3 by 3 is 1, and x squared by x, you get x. Divide 9 by 3 to 3, and the x's cancel out. On the right side, I need to take something too. Now, looking at this real quick, it doesn't really seem like there is a greatest common factor, but I have to take something. And I always at least take out the sign. So in this case, I'm going to take out a negative 1. And when I divide everything by negative 1, I get a matching x plus 3. And that's important. That's called the common quotient. If you're not getting the same thing in both parentheses, you're doing something wrong. Then the last step in the factoring process is another kind of grouping phase where I group your GCFs together. So the left GCF of 3x and the right GCF, negative 1, they get combined to be a binomial of 3x minus 1. And then I list my common quotient just one time, x plus 3. So it factors to a double pair of parentheses, or double parentheses, just like regular trinomials does. It's just a lot of extra work to get there first. So that's it. That's AC factoring. Now, if this was an equation, like say it had an equal 0 on it, then we would set these equal to 0 and solve them one at a time. But that's not, this problem didn't have that to start, so we're not going to do that here. And how about difference of two squares factoring? DOTS, difference of two squares, DOTS. Looks nothing like AC factoring. First of all, it's only 2 terms. That's what the T stands for 2. The D stands for difference, has to be a minus. And the S stands for squares. 25 is obviously a square number. When it comes to variables, even exponents are considered square. Dots is real simple. There's really just one step, the answer. And dots is a kind of a pattern concept where it's always one plus in the middle, one minus in the middle. When it comes to the variables, you cut the exponents in half. So this would be x to the third, x to the third. And the other piece, variables cut in half, so it's going to be y squared. But the square terms, we do the square root of them. And so that would be 5y squared and 5y squared. You need to look at your dots a second time, or you should really look at all your factoring after you factor and say, can it be factored further? Is there a GCF? Is it a dots? Like I have a minus sign. Is this also a dots? And sometimes it is. But this one's not a dots anymore because 5's not squared and 3 is an odd exponent. So that's as far as that one can go. All right, so that's just some factoring review. Operations with polynomials. First, simple multiplying. Sometimes people call this FOIL, where I got to multiply the first, the outside, the inside, the ass. But really, what it is, it's just distribution. I have to make sure that everything in this first term, A, gets multiplied by everything in the second term, B. So, it's distribution. And no matter how many terms I have over here and how many terms I have over here, take the first term on the left and multiply it by everything on the right. And so 2x times 3x is 6x squared. Remember, they're not like terms, but multiplication doesn't care about like terms. And you just multiply the common pieces. Multiply the 2 and the 3, the x and the x. And then we have 2x times 2 is 4x. So we distributed 2x. And now I got to distribute the next thing over here. The next thing over here is a negative 5. Multiply it by everything over here. Negative 5 times 3x is negative 15x. And negative 5 times 2 is negative 10. After you distribute, look for like terms. We have them in the middle. Combine them. So 6x squared minus 11x minus 10 will be our final answer. And there's no more like terms to combine. Remember, addition requires like terms. Multiplication doesn't, but addition does. So that's it. Similar concept over here. It's just more polynomial operations. Now, when you have something like 5 times something squared, like if, make this simpler, like if it was 5 times 3 squared, sometimes people get confused. Do I do 5 times 3 then square, or do I do 3 squared then times 5? Well, PEMDAS tells us you got to do the exponents first. So in this case, I'd have to 3 squared first to get 9, then times 5. And that's what we have to do here in this case too. I have to do the x plus 3 squared first before I distribute the 5. So that 5 is just going to kind of hang out and wait its turn. So what is x plus 3 squared? I'll do this over on the side. X plus 3 squared. Remember, that is a binomial squared. That means I have to do x plus 3 times x plus 3. This concept comes up a lot in Algebra 1. It comes up in geometry. It comes up in Algebra 2. Because a lot of people want to just square the pieces inside. You can't do that because it's a polynomial. And when you multiply polynomials, you have to do distribution. So we have to distribute. So this is really x times x, x squared. Here we have a 3x and another 3x. Let's do this, x squared plus 3x plus 3x. And then a 3 times 3 is 9. It combines to be x squared plus 6x plus 9. And if you recognize the pattern, some of you could kind of probably just do that in your head. And then minus, in parentheses, x squared minus 3x plus 1 is still there. Now I could distribute these pieces. I could distribute the 5 here. That's going to be 5x squared plus 30x plus 45. I got to distribute this. This is just like distributing a negative 1, distributing a negative. So minus x squared plus 3x minus 1. We distribute the negative 1 to all these things. Combine like terms. We have a 5x squared and a negative x squared. They're going to combine to be 4x squared. A 30x and a 3x will be 33x. And a 45 minus 1 is 44. That's it. Okay, solving literal equations. Literal equations are just like solving equations. In this example, this is the volume formula for a cone, actually, but you don't need to really know that. You'll learn about that in geometry, but I want to solve for r. I want to get r alone. Now, right now, it's v equals 1/3. Now, pi r squared, it means times pi times r squared. I'm trying to get this r alone. The exponent that's attached to it, I got to deal with that last. I got to get rid of the other stuff first. Now, you guys know from my previous videos that I like to get rid of any fractions first. Like this 3 that's down here, I'm going to multiply everything by 3. And in this one, on this side, it actually cancels out. So basically, I'm just multiplying 3 to the other side to get rid of the fraction 3 here. I don't have to multiply each of these things by 3 because they're all being multiplied as they are. So this is really just one giant term times 3 cancels that out. And this is times 3. So that turns us into 3v equals pi r squared. And they're being multiplied, so I get rid of the pi by doing the inverse, which is division. So divide. And so 3v over pi equals r squared. And then the way we get rid of the squared is the inverse of that is square root. So r equals the square root of 3v over pi. Now technically when I square root both sides, I have to add what's called a plus minus symbol because, well, you know, I don't want to talk too much about that now. You're going to learn more about that when you're doing completing the square. That comes up then, which is probably something you're doing soon if you haven't done it already. But just remember when you square root both sides, you got to add a little plus minus symbol. We'll talk more about that another time. Last thing in this video I wanted to cover was inequality graphs. Now, first of all, we need standard form. It's not going to be y equals mx plus b because it's an inequality, but it's going to be y is less than mx plus b or y is greater than mx plus b. Either way, I need y alone. So there's a couple of things on the left I don't want here. I don't want 3x. I don't want the 2. I just want the y. We start by moving the things not attached to it. 2 is attached to it, so we deal with that last. So the 3x is not attached to it, so I could subtract 3x to the other side. And that's going to give us 2y is less than. Now, the order in which I put these, it does matter for graphing purposes. Remember mx plus b, like y equals mx plus b. Your constant should go last. So the 4 right now is a constant, and the mx is negative 3x. So I got to put the negative 3x first and the positive 4 second. Then I could divide by my coefficient. I'm not flipping my inequality sign because I'm not dividing a negative. I'm dividing by positive. So it's going to stay less than. Negative 3 over 2. It's perfectly normal for our coefficient of x to be a fraction because it's slope. Plus 4 over 2 is 2. Graph these very similar to regular where I start at my y-intercept is 2. And then I use my slope of negative 3 over 2. Just down 3 over 2. Down 3 over 2. Down 3 over 2. But remember for inequalities, after you make your point, don't just draw your line like you're used to. You have to decide, is this going to be a solid or dotted? In this case, it is a dotted line. It's dotted line because we don't have the equal to bar. And so we want to make, little dashes or dots, something like that. Usually I just make slashes through the points that I already made. And then the last thing is the shading. Don't forget to shade. I have to shade either above or below. Now, because it's a less than symbol, I'm going to shade below. And you could do test points and different things to help you figure this out. But I like to use the y-intercept. The y-intercept is 2. 3, 4, 5 are greater than it. 1, 0, and the negatives are less than it. So since these are the numbers less than my y-intercept, that's the side I need to shade on. So it's going to be this side. So I'll shade this entire side because this is where the y-axis is. That's less than my y-intercept. Okay, and that's it. Graphing inequalities. A lot of times we graph 2 of them to do a system, but that's still just that same process. All right, that's it for Algebra 1, Regents Review 3. See ya.